So till I think till today, so in past 3 days we have discussed about the fundamentals and some fundamentals behind the threat, or you can say at अच्छा उसने स्पीकर पर आउट कर दिया ओके सॉरी okay. So applications of machine learning, or you can say GIAN security, is that cyber threat identification, right, where you want to basically detect the malicious activities and you try to basically stop attacks. Then you can say that enhance, you can use basically AI models to enhance human analysis. AI can be used as assistive tool to identify the threat, or you can say the attack. For example, the current state of art, people are trying to use LLMs to identify the threats, right? They try to model, they try to identify the threat, and then of course defense measure you have to plan, you have to basically find out. Then fighting AI threats, basically this is the defense, you can say, using ML models to automate repetitive security tasks, using machine learning to close zero-day vulnerabilities. Right. So whenever attacks come or some sort of abnormality comes to the system should be able to defend it immediately. So we call it zero-day attack, zero-day attack defense. You can say many times you can monitor the emails. So system automated basically monitoring is required. Whether you have a harmful email, a spam email, you can say, or it is basically genuine email, or you can say it is basically legal, legitimate email. Then there are some other applications you can say where you can say AI based antivirus software you can design. You can basically model the malicious behavior of a user. You can model the user behavior and you can identify the malicious behavior or malicious activity a particular user or client is performing on the system. These are the types we have already discussed, that model and parameters are known. So white box is everything is known to you. So you can design attack, you can design the defense, and you can basically build a robust system, customized robust system for your applications. Black box is basically model and parameters are unknown. So the organization basically who basically develops a model, they do not basically disclose their model, right? So only the interface are known. So input, what dimensional input you can provide and what output you might get. So only the pins are, you can say, if you design your AI model in the hardware. So idea is you have a input pins and you have only the output pins. So you don't know anything internally, right? So the idea to attack on these systems, even to identify the vulnerabilities, is to generate the samples using that model. So just see the response, generate sample, see the response, collect the data, try to see that what type of vulnerabilities this model might have. Generally, it is basically critical when we are talking about the authentication systems, critical region authentication systems. Poisoning attack, I have already discussed that Dursel, you just perturb the trained data, mislabel the data, right? Evasion attack, that again we are doing at the inference level, right? So model is already trained, but we want to attack on the system, right? So you can do model extraction, you can call it cloning, or model extraction is basically you are extracting the parameters from the model. So the way is basically model extraction is basically, suppose someone gave a black box setting model, right? You don't know the parameters, but suppose the computation is going on. You try to understand the computation behavior, You just plot all the power analysis at a very fine level from the chip that you have or from the hardware that you have. You just try to monitor and then you try to map the computation, how many multiplications are there, how many additions are there, and based on that power analysis, there are recent basically attack mechanism, power analysis attack on model extraction. You can get a very recent paper, I think it was in host A-star conference in security. So you can extract the model, right? So at the hardware level, right? That is challenging little bit. You have to basically develop the system for that. But of course, you can extract the model even in black box setting. So idea is people try to confuse the system so that you should not be able to predict whether the computation is going on as addition or multiplication or subtraction or division or any floating point operations or integer operations. So we try to just defense, I am just telling you. So if you want to basically defend your system against this power analysis based attacks for model extraction, what you do, you just put dummy computations there. So number of multiplication, number of addition, everything becomes similar, so that you cannot identify the pattern. So that is one of the defense people might have proposed. You can start working on that. Just get that paper and you just understand that, and maybe you can do something. Another one is basically training data. You suppose in a black box setting, you don't know any of the sample that was basically used in training. So idea is, can we identify the set of training samples, training examples, or can we get the distribution of the training data on which the model was trained. For example, nowadays we are saying that ChatGPT, or you can say Gemini, DeepSeek, or many other LLMs, or you can say conversational AI models, they are trained on large volume of data that is available in public domain on internet, right? But we don't know that on what data it was trained exactly. So just a very superficial, or you can say very abstract knowledge we have, because the document or the report that is released is not exactly saying anything about how much data, and so that is a very abstract information. So let just example of that ChatGPT can be identify on which data it was trained. So that threat says that it is a model, basically you can say membership attack, we said. So we try to identify the members who were used to train the model. Once you get those things, then this is also basically violation of a privacy, data privacy. Maybe you have a system which basically contains the information, some sensitive information, and you are able to extract those information, then this is a privacy violation, right? Legal is there, but before going to the legal things, one thing is that if you are basically able to identify the data, actual data, so it is a privacy leakage, right? So it has lot of security concerns. So these are the adversarial approaches, adversarial sample generation. So try to generate the samples which can basically bypass the model, which can basically fool the model, and accordingly you might have some defense system. So defense is basically you use the same scheme to generate the samples and put in the training data, get the robust model trained, right? So that it can take care of these type of attacks, right? So fast gradient we have already discussed, Jacobian based, that is similar to this fast gradient. You have to compute the gradient. Jacobian, I think everyone knows that you have to compute the gradient of a tensor with respect to the tensor, right? Or vector with respect to the vector. Then deep full library is there, so deep full attack is there. You can just toolbox is there. Full box is also one of the toolbox. You just try and use. So many algorithms you will get. Open source approaches are available, you can get it. This is another popular attack, CW attack, collinear and Wagner attacks. So, similar to the sample generation that we have. Then GIAN based attacks. So, in today's session we will try to discuss about the GIAN, generative adversarial neural network based attacks. And yesterday a bit discussion, right, I got request to discuss explainable AI, right. So, we will do basically 1 hour on explainable AI, and then in the afternoon session we will try to demonstrate both the things, GIAN and explainable AI. Right. So, these are the attacks, popular attacks available, you can get, and open source is available. You can get the code, you can execute, you can just see that what is happening, right. So, we are focusing on GIAN today, right, because GIAN is also the modern, or you can say the current state of art for basically generating adversarial samples, because it has capability of doing whatever you can think. Only the challenge, or you can say the problem is that how will you design the loss function appropriately. For any sort of task, if you are able to generate, or you can see you are able to find the correct loss function or good loss function. So, GIAN is capable of solving all the problems. It can attack the system, it can defend the system. So, both the way it can work, right. But it depends what heuristic you have used to basically get the appropriate loss function for your task, right. So, we have two component in adversarial sample generation using generative. Generative is basically, the name generative says that we want to generate the sample. The underlying principle behind this GIAN is to generate the sample. A is adversarial. A, it can be anything, it might not be adversarial even. You might want to basically generate or augment your data. Even you can generate the samples using this GIAN. I think yesterday people asked that how can we augment data if we do not have anything, right. So, GIAN is the hope, GIAN might be the solution. So, we will discuss, and there are some other neural network models like variational autoencoder, right, you might have studied. So, what variational autoencoder does, whatever data you have, so it try to basically model the Gaussian mixture of Gaussians, right, distribution. So, mean and variance, many mean and variances it learns, and then it try to basically generate the data. So, these are because autoencoders are basically the neural network model, while the labels are the data itself, and the task is to basically encode the data from high dimension to the low dimension, right. So, given in high dimension data, you have to encode it into low dimension data, and then you say that okay, this is you can use in embedding, right, word embedding, or you can say sentence embedding, text embedding, image embedding. Autoencoder is the basic model in that direction, and variational autoencoder basically mimic the distribution parameters. And once you know the distribution parameters, so for example, suppose you have a Gaussian distribution. So, what are the parameters for a Gaussian distribution? You need a mean and you need variance. If you have these two parameters, you can sample infinite many samples, right. So, likewise you can say uniform distribution, you can have the coordinates, right. So, of that uniform distribution, or you can say the size of the rectangle, you can say. Likewise, as a distribution you can. So, you have parameter, you can generate as many as sample you want. So, given a data set, we try to get the distribution parameters, and then as many as sample you want, you can generate, right. So, you can augment data itself, right. So, suppose you have a small number of samples, let you have 1000 samples, and you have correctly basically modeled the distribution from where these data basically were sampled using variational autoencoder, right, or using this GIAN, and then you can say that okay, you can generate the samples and you can populate the data. How many samples you want to, it is up to you. until your model is stable, right, or robust. So, in GIAN basically we have two components. One component is called discriminator. So, the task of discriminator is to basically decide something. So, it might be the actual model, it might be the victim model, you can say, on which we want to perform attack, right. So, discriminator is just, you say this is a black box or a victim model, or you just assume that this is the decision maker, right. So, some decision maker is there and we want to attack that decision maker, right. So, that is the simplest thing. So, discriminator is the actual system that you have, or you can say you want to attack on that system. We have another component, we call it generator. So, objective of generator is to generate the samples, generate the input data, so that if you want to perform attack, if you want to design attack, it should attack on the discriminator, right. It can bypass the discriminator, like adversarial sample you have done, you just put certain noise in the data and it tries to basically change the decision, right. So, same thing here. So, you try basically generate the data, the objective of the generator is to generate the data and that input data should be able to fool the discriminator or victim model. Another one is you just make a generator such that generator is capable of getting the capable of generating the data for which discriminator is giving always the correct response or targeted response. For example, your discriminator is a digit classification, yesterday we discussed image data, right. So, you have a digit data, so 0, 1, 2, right, you have image data. So, every image contains one of the digit, either 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So, 10 classes are there, are 10 digits were there. So, your task is to basically once digit is given as an image to you, so you should be able to classify it correctly. Here suppose discriminators is doing the same thing, so it is capable of classifying or basically telling you about the digit present in the image. So, we want generator to generate the input such that it will start saying that this image contains digit 1, this image contains digit 2. So, accordingly you can generate the samples. You just generate the samples for which the discriminator says it is 1. You say that no, we want to generate sample discriminator for which decides for 3. You should just say that generate data, generate sample for which discriminator will say it is 3. So, you can generate any class sample, whatever class you want to target, you can generate those samples. Then another thing, you can design the generator such that the generator model, generator is also a neural network by default, or you can say the standard model that we have. So, generator you can just learn a generator model such that its accuracy is similar to the model accuracy, discriminator model or victims model accuracy. Once you reach the accuracy level of basically discriminator, your model is cloned. And you can get lot of papers, recent papers, they say about the student teacher model, a student teacher model. So, idea is you say discriminator is the teacher, right. So, which basically decide the, and generator is basically the student, basically student when arrives, right, when basically register for the class, they have a very minimal knowledge. And in due course of time, when you basically generally teach the student, then during the examination or after the course, so they might be having more knowledge than the teacher, or they might have equivalent knowledge to the teacher. So, that is the true story. So, here you can say discriminator is the teacher, generator is the student. The task of generator or you can say student is to basically achieve the accuracy as this teacher is, right. So, teacher has. So, this is called a student teacher model. You can get lot of papers on that, maybe you can Google and you can get it. So, you can clone the model. In the previous setting where you are generating the sample for which discriminator is able to decide it, you are able to basically bypass the system, right, or fool the system. That is called basically you can say that thief and police system, right. So, police ask the question to the to a thief, right. Thief try to basically somehow moderate the police or interrogation, right. And once the thief is able to basically bypass or moderate the things, you know that what might happen, right. So these are the philosophy behind these models, behind this basically model when it was basically developed. This is the structure. Here we are assuming that discriminator is also the neural network. So discriminator might be anything. Discriminator is a black box to you. It might be supported machine model, it might be decision tree model, it might be random forest model, it might be ADA boost, or any type of ML model you can say discriminator might be. So only it has access to you have access for this model is only the input interface, and you can get the response whatever it is providing, right. So this is one setting when we assume that discriminator is a victim. We want to attack the discriminator. Now I am just coming to the positive part of this approach. The same approach. We are trying to generate the sample, and discriminator is not now is not in black box system. It is white box. You are able to retrain it. So what are we doing? So whenever we generate a sample from the generator, and we feed to the model along with the training data that we have, we say that this is fake sample. So we design the loss for the discriminator that for fake samples please decide the badly, right. So don't give the correct solution. When you see this generator is generating a sample, just give a random solution. One idea I am just giving, right. So generator will not be able to train it itself, because it has to train on the discriminator loss, right. And discriminator is now little advanced, and discriminator is fooling the generator. So generator will never be a good model, right. But what we can do, so we have a distribution, true data we have now access to the trained data, or trained data you have. Generator is generating the sample. So we are adjusting our model such that our model becomes robust, and whenever people want to attack using GIAN, so our model adjusts itself and it prevents that attack. Same model you can use, but only the philosophy changes, right. So like in adversarial sample generation defense, what we are doing, so we are saying that okay, we will also do the same thing. We generate the adversarial samples, we populate our training data with, we add that adversarial sample to our data, and we retrain the model or fine tune the model, right, so that it can detect this is adversarial sample, right, or we want to make our model robust. So just say here, so generally generator is started with the random noise, right. So whatever garbage you want to provide, you just put that. So just input the random vector. So this is in your reach. Just see here in the generator, right. So you have a random uniform sampling. So any number of basically any distribution you just assume Gaussian uniform. Generally Gaussian distribution is assumed, right. You might not have access to the original data. It is not necessary, but here the task of this model is to basically generate the samples, generate the sample which follow the true distribution. So here we are trying to model the training data distribution. So the task of discriminator is to, whenever generator sends the sample, it says that this is a fake sample, and whenever data comes from the true distribution, it says that this is a true distribution. So discriminator is only able to decide whether this is a fake or true, and generator basically keep on generating the samples until the this discriminator starts saying this is a sample from true distribution. Once the discriminator starts saying that whatever sample is generated by the generator is belongs to the true distribution, its job is done. Right? You are able to generate or basically get the distribution of training data, for which model is saying that you are this is a real data, it is not fake, right. So, this is called DC GIAN. You might get the basically huge tutorial on TensorFlow library, right, TensorFlow project. In Google Colab you might have that. So, how the basically learning happens? You have a generator loss, because we have to train this model as well, parameter you have to update for the generator. For discriminator it might be simple black box, or it might be retraining itself, so that whenever fake samples comes, it is able to decide whether this is a dot cell sample, right, and accordingly it will take the decision. So, you have a basically discriminator loss and you have a generator loss, and both the loss you have to optimize. So, generator basically try to fool the discriminator, and discriminator try to adapt itself, right, to improve itself. So, this is the basically loss function. You can say you have a discriminator loss, right, then you can have a basically generator loss. So, accordingly you can decide. Generator loss is very simple. So, whatever output we are getting from the discriminator, based on that we are trying to adjust our generator's parameter. This is one of the sample example I am just giving you here using this GIAN. So, this is the actual image. Can you see 8? We do not have any access to the true distribution. We want to generate the sample for which model says it is 8. So, can you see the second one B? B, C and D. Can you identify 8? Right. But model says that this image belongs to 8, is sampled from distribution which basically decides about 8, which basically looks like 8. So, you can see that it is not necessary that you always get the sample which is basically similar to the you can say looks like original image. Even you can have a garbage model can be fooled, right. Even people do not know that what is going as input. So, you can say this might be the cipher image, encrypted image, right, and your model is able to decide, tell something about this. It is saying that this is 8. This is also one of the attack, right. Your model should not be should not accept this. It should say that, for example, face recognition system, when you so face recognition system works on the face, human faces, right. Whenever it basically comes to the some animal face, you just put right to this machine, to the system, it should be able to decide. It should say that this is not a human face, right. Otherwise, it will classify to some class, right. You know that if you have multi-class setting, so all the classifiers that we have in multi-class classification, so one of the class will be assigned, right. So, suppose you have 100 student and you have to just identify the person, given an image you have to identify. So, you have 100 class classification data, right, you have trained on that. Now, whenever a person comes, it has to decide on those 100. So, it has to classify to some of the class, right. So, in multi-class it is you have to decide for one class, maybe many times you want to decide on many classes. So, multi-level classification is there. For example, in news classification in many places you can say you can label a particular news as a political, right, you can say that maybe academics, right, news basically you can say entertainment, political, many things you can just decide. So, those are multi-level classification. So, here the idea is to generate the sample such that model basically just knows that this is a 8, but human does not know. Now, the benefit of this is that you just generate samples for digit 8, digit 7, digit 0, digit 1 and just train a model, new model on these samples. So, that model whenever people will try to attack to get the distribution of the training data, they will not get the actual thing, because 8 is different, right. So, it looks like human looks if you do not give that 8, right, the image A, human will not be able to understand what are the digits here in this image. So, even you have a very strong attack mechanism which basically decodes the data training data somehow on which the model was trained, you will get these images B, C, D, and once you get these images, you will not be able to understand what is the input, right. So, this can be used for defense. So, you generate these type samples, train the model, because you will get your model will work for those A also, B also, C and D, right. It will accept the original distribution also and this adversarial distribution as well, and it will train right itself. So, for example, you see here, so these are the digits you can see. So, we have equivalent data. So, you have a digit 5, digit 0, 4, 1, 9, 2, 1, 3, 1, 4. You can see here the corresponding images are here. So, these are the adversarial images generated, right. That looks like garbage, but when you see the distribution, so when it comes to the original distribution, so original distribution might be overlapping here, but when we add the generate the samples from generator, and you can say that if you visualize the data, right, using TSNE, one of the dimensionality reduction or low dimension representation of the data, you can plot it. So, you can say the second one is clearly you can see that accuracy will improve because it is clearly identifiable groups, right. So, all digits are separated in some sense, but in the first one you can say that it is visually little bit overlapping. So, you can get benefit on that, you train on this one, maybe you can mix something from the original as well if you know, otherwise you train your model on this data, and membership attack you can defend your model from membership attack. Okay, this is another story. So, you can say that you have a model, huge model, maybe you want to basically embed your model to devices, IoT devices. So, huge models or bigger models you cannot afford, you have to basically develop lightweight model. Lightweight means you have to reduce the number of parameters. So, once model is trained, so there are two ways of basically solving this problem is that at basically learning time you try to basically put some regulation so that model size is less, number of parameters that you have is less. Another one is the model is already trained, you cannot afford retraining. So, idea is you just try to apply some approaches which can basically make your model sparse, because for many of the tasks, so all the parameters are not required. So, you might have a GPT, you have a chat GPT or DeepSeek, so they might have many billions of parameters, but your task is to just understand something or just do the translation. So, for translation those many parameters are not required. So, for your specific task you just try to somehow make the customized model, right. So, you just forget many of the weights, or you can say remove many of the parameters such that your accuracy is intact. So, you can come up with a very small size model. Small size means whenever I say that number of parameters, effective parameters I am just telling you, or you can say active parameters required or less. You cannot change the model architecture, but many parameters you can put 0. So, whenever you want to design a chip or you want to fabricate model in the hardware, you need less memory. So, you can come up with a lightweight representation, lightweight basically module in the hardware, because that is very costly. Memory is very costly when you put right the data on the board, right. So, here you can embed your model on FPGA and then you can do the production and others. So, we are not going into that one basically. So, this one we have already discussed, right. So, you just put certain image, so 0.007 is epsilon. These are the few applications you can see here, right. So, because you can assume the scenario that in coming years most of the autonomous systems we might have, right. Maybe autonomous driving So if your city is a little infrastructure is very good, right? So maybe you can system can come up with this autonomous driving car systems. So then these attacks are very challenging, right? So to defend. So suppose some stop board is there on the side, right, roadside, and you know that what features are basically used to detect this stop sign, because you have a vision system, right, on your car or on your vehicle, autonomous vehicle, and you just put one dot. As adversary, you just go and put one dot at one place. That might be, you know that this particular region is very sensitive. Model will be fooled, and it can harm to the humans, right? Accident can happen. So these are the challenges if we are doing autonomous. As a human, we know this is a stop sign. If human is driving car, so human will stop. But if it is autonomous driving car, right, humans are not involved in the driving, then you know that adversary what can, right? So what can happen? Even in dialogue system, so this is another type of attack, spear phone, right? So you are communicating with one of your friend, right? The vibration data from your speaker, right? If you store that, if you record that as an adversary, right? You can say in the middle as well. You can say if you are able to get a speaker phone vibration, you can identify that what communication is going on. Right. So few things you can directly tell, right? So suppose some fighting is happening on phone. So the pattern will be very different. You will get that some fighting is, but if you want to correctly decode that what communication is happening, you can use that data. And in the past, people have used this system, and they decoded the communication, right? What is going on? That your adversary can do. Even you can do the setup, and you can get. So this the text data you can see here. So can you see the text that we have here? So this is a unique masterpiece made by the best director ever lived in the USSR, right? One word unique was replaced with this word soul, right? So this is a soul masterpiece. The meaning, you can say that meaning is not changed, semantic is not changed from the text, but the label changes. With 99.7% confidence, it was saying positive for the first one when the word was unique. Then when you have replaced with the synonym, right? Semantic is same, human understands well that this has the positive semantic, but model starts saying that it is negative with 86.2% confidence. So that's the attack, right? Adversarial attack, poisoning attack. We perturb the data in some sense, and it starts saying different class. So there are some cryptographic attack. You can decode the key, right? So these are the some research papers on this adversarial sample generation and attacking on the models. And most of the codes are basically available as a open source, right? So few defense strategies we want to discuss. So one is basically for data privacy, you can anonymize the data, right? You just remove the information, user information, because many times people do not share the data from you can say medical data and other records people do not share. The reason is data privacy, right? We do not want to basically share the information of any patient, right? Patient name, patient disease, right, to the public, because that might create certain concerns in the society. So that's why data and anonymization techniques are people are using there. Some encryption approaches people are using, but you know that encryption algorithms are basically costlier in terms of time complexity and resource, right? So this is one thing for data privacy. Then you can say encryption techniques can be used to encrypt the data, differential privacy. So instead of Giving the actual data, you just say that you add a small amount of random noise to model the parameters, so that your model is a little robust, right. So, during the training process, you just take care of adversarial basically samples. Then distributed learning is basically, you can say, federated learning setting, when you say that okay, do not train model on one particular part of the data, you can say allow multiple users to train locally and global model, and data privacy can be ensured. But yesterday we have shown that Trojan can be there in the model. If the basically server or global model is itself infected, then there is a problem, right. Then regularization technique, of course, to reduce the model size, and of course try to give you good generalization accuracies, right. So these techniques basically try to basically regularization based, or you can say distribution learning, distributed learning, right. They try to make your model little robust, right, prepare against the defense, basically against the attacks. Maybe you can see attack resistive models, right. You can use encryption, and you can get few of the basically machine learning models which uses basically encryption technique to for training, right. For example, you say that you have a data, you encrypt it, train model on encrypted data, you will get encrypted output. Then if you have a key, you can decode it. So that model, attacking on that model is little complex, but the challenge is that this encryption scheme. So encryption, if you are using the hard encryption, so it will be very costlier. If you are using a very soft encryption, or you can say relaxed encryption technique, so you can identify. For example, Caesar cipher you are using, or homomorphic encryption you are using, right. So they can be easily decodable. So attacker can decode it, so defense might be little challenging for those things. So people are working on this. It is not like that people have stopped working, so they are trying to get the process, so that either you can for basically if you want to prevent your model from the cloning, you just try to model extraction attack. You just try to encrypt your model weights, or try to get certain defense mechanism. If you see that data is adversary, input is fed as a, you can say, adversarial sample. If your model or you can say ML as a service model is able to decide that the input that is coming is adversary, so just give a random output, right. Do not give the correct output. So if you give correct output, then there will be a challenge. So generator will train it, adversary will learn. So whenever you just put a garbage input to the model, so model is able to decide and it tells you about the garbage. So model extraction attack will not do, because you do not know that what is the correct output model will provide. Model is just generating the random responses for you. Once model ensures that the input that you are feeding is fake input, or you can say adversarial input. So these are the defense mechanism, recent defense mechanism people are working and getting paper published in that. So you can get one of my paper on basically basic idea on archive you can find, right. So our team is working in that direction. So they are trying to basically build a defensive model which can be prevented against these adversarial attacks, right. Then demo, so we will share, I think I have shared this code, this library, right. So and have you gone through that? So it has a Python flavor. So though it is there in a command line system, so it has now a Python flavor. You can just import that library, text attack, and you can just do very simple programming. So we'll show in the demonstration session. So all the papers that we have shown yesterday, so they are all implemented, and you can just compare them. And very quickly you can come up with your own idea if you understand those papers. What is the time? So So, we have quickly covered that GIAN part, by the way. So, we have not discussed about a lot of things like generative process and others. But if you want more details, so we can do in the basically tutorial session. So, explainable AI. So, this example I have shown, right, I think on the first day or second day. So, we discussed that, we told you that model is giving around 96% accuracy, but when you try to basically investigate, right, in some sense, try to basically see that what features were basically used to decide upon, you will find that only the corner features in the image are used to decide whether the this X-ray contains COVID-19 are infected with COVID-19 or pneumonia, or this is normal in X-ray image. This was due to the source noise from where the data was generated. So, here if you are not able to basically plot this, you are blindly have developed your model, you will not understand why model is failing on test data. Right. So, just go and just see that what features are important and on what feature decision is there, then you will be able to understand that what sort of features it is looking. So, here looking into this, the right hand side, you can see the gradient we have plotted, you can say. Only the features, corner features in the image are important, but we know that if you have a medical data, so most of the time you can see the actual basically problem basically lies inside that, right. Generally the central position you can say in the image, or some location, different type of location in the image, that can be identified by the experts. But here none of the images basically have information, or you can say the features at the corner of the images. Whether it is MRI, whether it is ultrasound image, whether it is X-ray, similar same is true, because at the corners generally people basically hold the X-rays and they might be corrupted. That is why the main data is available in not at the corners inside that. So, looking into this gradient visualization, you will easily understand that there is a problem in this model. Data is your model is not able to get the features from inside the image. Only the corner images are corner features are used to decide. So, it will, of course, it will not work in the real time, because you are able to understand, right, why model is working, why model is giving 96% accuracy and validation data, training data, but when you deploy it in real time, it is not able to perform well. So, now you know that. So, this is explainability. Once you say that your model is performing 96% with 96% accuracy, so you just provide explainability why 96% accuracy, what are the features it looks into, right. So, that investigation is required. So, explainability says that if you have a model, you just provide why model is working. So, this will basically build the trust on your model. People will see that okay, because of these things, obvious thing, or you can say these are the features important, and for that model is working, right. And this is very important when you are working in basically medical domain, drug discovery, right. You might be saying that why a particular disease basically is triggered, right. You say that okay, due to this problem, due to this problem, due to this problem, due to this feature or this problem, you have fever. Because suppose a person has fever for 3 or 4 days, right. So, you have to go through many diagnosis processes, right. It might be dengue fever, it might be you can say jaundice fever, it might be some typhoid, right. So, there are many classes for that, many types, and different sources are there which can trigger the fever, right. So, you have to identify that why you have got the fever, then proper investigation and proper medication, proper treatment can be planned, right. So, that is why if your model is giving you the accuracy, or you have a model, so you have to investigate these many questions. why a specific output is generated. Many times people hide it due to certain privacy and due to certain copyright issues or IPR issues. Bridging the gap between black box models and human understanding. So, for example, ChatGPT is providing certain response. So, why we rely on the response, right? Many times it does not give the correct response, and for most of the time we rely on that, assuming that this because it is basically getting the data, it has been trained on some public corpus, internet corpus, it might have more knowledge, right, and it provides the response. But as a human, you can say understanding, or as a human, we are not confident, right, because if you know ground truth, you know what is the correct answer, you will say that ChatGPT is wrong, but if you do not know that what is the correct answer, then you can't say anything, right. So, here why model is working, bridging the gap between black box models and human understanding. So, mostly whenever I am just saying that black box model, so most of the black box model are basically on cloud, hosted on cloud. So, you can just put input and you can get the response, right, query and response. If your model is explainable, you can build the trust and accountability in AI systems, right. Why model is failing, you can, what are the things which basically responsible to fail the AI system in real time. For example, some attack happened, right, or some sort of accident happened, some satellite failure happened due to the AI system. So, they must be accountable, right. So, why this happened, right, why did this happen. Then ethical considerations. So, ethical AI is one of the popular phenomena nowadays we are discussing in the community. So, ethical AI, so what are the right uses of AI, what are the wrong usage of AI. So, right uses generally you say that benefits to society, right, wrong uses that might harm to the society. But this is a debatable question, many times ethics whenever ethics comes, it is a huge debate can happen, right. So, something might be good for you, something might be bad for the thing that is good for you, that might be bad for others, right. So, ethical considerations we have to think about. Then regulatory compliance, what are the policies, government policies, what are the basically other state policies, right, that drives that can drive much. If you have explainability in your AI system, you can get what are the features are important that we want to capture. So, we design a system so that those features, strong features, are the features which are basically important for decision making. So, we have to capture them. Inference boundary you can draw, right. You might get certain decision boundary. So, where your model will fail, or what might be might happen in certain scenarios. So, that inference boundary you can get, and of course, visualization you try to visualize. So, all these things investigating into certain questions, certain query, and certain concepts, certain beliefs we want to basically build with this AI, right. So, or into this AI system. So, maybe you can ask that why biometric system works, right, why the fingerprint recognition system works. Yeah. See, if your explanation is wrong, right, maybe it is basically under certain threat or attack, explainability is wrong. So, when we talk about AI, so first fundamental question is why do we want to work in AI? What is the need of AI, right? So, whenever you do not have a deterministic decision, right, so you are not certain about decision, right, 100%. you have uncertainty in the decision making, right, then we need AI. So, AI basically enhances, assists us to get a basically in practice many times correct decisions, and many times why I am saying that not always. So, that is the uncertainty part, that there is a gap. So, that is the reason the AI systems or the model that we have, so they are not able to reach to the human understanding, right, human intelligence yet. Of course, they are scalable. If you have AI machines are doing the computation, then of course, they are scalable. They can perform lot of queries at once, concurrent queries. For human, we have limitations, certain limitations, right. We can respond to many queries in once, but your system can do. So, scalability is another important thing that machines do. That is the reason, and always you do not have reached to the experts. So, if your machine is capable of getting certain decision that was built, or you can say that has built upon certain experts heuristic, then for most of the people it gives the good response. I am not saying 100% correct, good response. That might be acceptable to the system, right, to the society, to the organization. So, that's why we are doing research, right. If everything is correct, right, and everything is available, right, so why do we do research, right? Why do you basically take admission for PhD, right, and you say that we are doing research in NLP or computer vision or something. So, because there are challenges, right? There are challenges, and we want to address those challenges somehow to build a robust system, robust mechanism. Though we are knowing that we are working in uncertainties, we do not know the correct answer many times, but even we try to get the solution which is basically good, which is acceptable, and which basically works in real time, right. So, of course, you can get basically you can have a bad explanation, you can have a good explanation. That depends on the, if you know the ground truth, only then you can say, right. Then you try to fine tune your model so that it try to give the correct explanation, right. So, that is why everyone is doing research in that direction. People are coming up with the more solutions, more robust solutions, right. Otherwise, it is okay, right. So, there are some standard mechanism in explanatory. So, we will discuss today that can enhance your model accuracies. You can say they can build a trust on the system, right. So, these questions you can somehow you can try to basically fill little gap, not the 100% gap, because explanatory might not give you the all the things clear, right. So, just give you something, some idea that why the model is working, and if you have a very complex model, then understanding that model is very complex task for humans. So, if your model is giving certain explanation, right, why the decision is made like this. For example, in the institute, in the organization, even in real scenario when humans are involved, so certain decision was made, right, and then some explanation comes to you why the decision is made, right. Suppose you say that all the night canteens in the campus is basically off by 10 a.m. or you can say night canteen, you can say they are not open in the night, so they stopped at 10 p.m. or 9 p.m. Then people try to ask the question, what was the reason it happened, right. Everyone will be curious why this happened. Let authorities give certain explanation, this is the reason. You might trust on that explanation, you might not, right. That explanation might not be aligned to your thought process, and that maybe what might be the reason. So, here the same thing might happen, because explainability you can get in two ways. One is you have a black box model and you have designed your own explainability mechanism, why the model is working. So, that is another story. We generally say that because we guess many things, right. So, this might be the case, this might be the situation why the canteen basically people shut off, right. But authority says different, authority gave different explanation. But as a system, as a legal system, you have to rely on the authorities. But in real, there might be some other scenarios, other explanations for that. You can come up with your own explanation. This might be the reason why the canteen was basically stopped, right. So, that the same thing is here. So, one is the designer will provide the explanation. Suppose I put my model on cloud, I will provide the explanation why the model works, right. Suppose I do not provide it, so you will try to guess why the model is working. Suppose you have a face biometric system, or you can say any machine learning model, maybe cat and dog classification model. Why model is deciding on cat? Why the model has decided on dog? Either model in the model you just put the explanation, or at the end we will say that okay, because dog has certain facial features, it might have a something, right. So, even you can say horse and cow. So, horse does not have thorns, right. So, you just see that there are some features as a human we can understand that this might be the reason the model is working, right. Actually, that might not be. So, one of the idea that we are going to tell you here, that you have a model as a black box, you have written your own algorithm to explain why the model is working. You just give the input, you get the output, you just compute the gradient. Just see which features are important to decide upon. So, most of the models that we will basically demonstrate in the post lunch session, so they are on this one. So, we have tools like Lime, SAP, right, SAPLay, and many other models approaches we have. So, because there was a boom, right. So, in industry everyone was basically interested in giving you the explanation for a model under black box setting. So, Google, Facebook, Microsoft, they basically started doing, but later on they stopped doing it, right. There might be certain other stories, but that is why we have many models available. You just use those algorithms, those approaches, you just feed any trained model, they will try to give you the explanations, right. They generate some sample, you just provide some samples, random samples, and why the output decision, particular decision basically came. So, they try to basically explain. So, we are skipping many things, so we are not going into that. So, one important reasoning is the best reasoning you can say is the first order logic, right. If your system, you have a system, you have a model, and somehow you are able to reason about the model, right. So, why the model is working, and you are able to represent your model as a first order logic system, right. You have feature sets in the data, you have a model parameters, you just try to build a first order logic rules, and if you try to mimic your system, your basically decision, or you can say the prediction or inference that model is providing. So, that will be the best explainability that you can have. So, that is why if you have a rule based system, so rules based systems are self explainable. You know that rules are simply the explainable system things, right. You know that if this feature has value greater than this feature has value in this range, this feature has this particular value, we decide on class this. So, decision tree are, you can say some sort of better explainable models, decision tree based, right. But even if you come with many such models like random forest, so they are forest of trees, decision trees. So, explainability is little complex there as well. But if you have a first order logic, your model is rule based or first order logic based, then of course you can your explanation is people rely on that explanation because that is self explanatory. Your model is self explanatory, right. But the complex model like generative pre-trained transformers, BERT, right, where you have a huge number of parameters, many activation, different type of activation functions you have used. You cannot mimic that function, right. So, that is basically try to approximate. Explanatory is very complex. The idea is you go layer by layer backward and try to plot the gradients after for the trained model when it is trained, right. And then you try to identify, try to discover why the model works, right. Because after the CNN layers, if you have a deep learning models, so most of the models for a computer vision data, so they use just CNN layers. So after CNN layers, they most of the model they have fully connected layers. So fully connected layer basically try to somehow combine the features in a way that the accuracy improves, right. So explainability, you can say that after the feature extraction, you can say when the how the features are basically interrelated or correlated, are basically combined together in linear or non-linear way based on the activation, whatever activation you have used, they basically decides. So that thing, if you are able to extract somehow, if you are able to present very easily, or that human can understand well, then you can understand many things. You can understand why the model is working, why the model is failing. So once you understand that why the model is failing, you can come up with the certain solutions. So that's why explainability is required for both. If you want to learn, if you want to design the system, if you want to improve the system, or if you want to build the trust or reliability on the system. Right. Suppose for human recognition rate, you say that your mobile number is the basically feature which basically decides upon a particular person, decide particular member. Then you know that mobile number might be the basically private feature, it might indicate data privacy, right. So you have to basically unlearn that particular feature. So many times there is another story in AI. So idea is this is the modern idea, people try to say that. So you just try to forget the whatever you have learned. This is called unlearning the model. Right. So you just try to train the model, after few epochs you just unlearn few things, then again retrain. So this is used to just make your model robust, reliable, right. So for explainability, you can use the existing methods, you can come up with your own approaches, but most of the approaches in black box setting will be that you have a input, you have output, input and output, query and response, question and answer, question and answers, and then try to build certain basically assessment. You just try to do certain assessment why model is behaving like this, what might be the challenges in the model, right. Then you can come up with some improved solution. And for explanations, one important thing that I want to convey here, simple explanations are better. If I give you very complex explanations, you have a 1 billion parameters in the model, we have thousands of rules, 20,000 of rules, so human will not understand, right. Even if you basically invest money or you do some LIC and others, so they have 10 or 20 pages booklet they generally provide to you. We don't go through that. Most of us basically just see that, avoid it. As a human, we want simplicity, right? And understanding the things is easy if the things are simple, right? So very complex model, if you make it understandable or explainable in a very simple way, and simplest way you can say that just a very simple first order logic rules. Because of this and this and this model decides on this. Because of this word keyword unique is present in the data, it says this is positive, but when the word soul comes, it says negative. So it means that model is more sensitive towards a particular feature that you have in the data. So simple is better. right. So that's why in I think previous slide, one slide from Brinley code, right, be put, right, you might remember in the first session. Maybe we can go there and build. So this was the reason we basically put that slide. I think somewhere. So this slide is just for explainability only. So getting a simple explanation is very hard, right. So that's why here the art of simplicity is a puzzle of complexity. So given a very complex model, how will come up with an explanation which is very simple, understandable. Right. So nowadays people are using LLMs, right, to provide the explanations. Right. So why the model is working? So that is the current state of art. I think very recently people have started working on this, hardly a year. So if you want to do research, you can think in that direction as well. Right. So generating the simple explanations, you might get explanations that might be very complex. We'll show you that challenge. So the existing tool, if you deploy them on neural network model, they might not give you the simple explanations because you have many parameters involved, billions of parameters involved, right. Maybe we can stop, right. So what is the time? And we can have a 2-3 minutes break, then we can continue, right. So, for NLP, right, so these are the few basically A star are good venues from where you can refer. If you want to see the current state of art, what people are doing, right. So, you can go to the www, KDD, CGIAR, ICDM, CIKM, TKD, NeuroIPS, ICML, ACL, UAI, SKY, III, CVPR, CoLink, COLT, right. So, like that there are many conferences. So, you can get I think A star conferences, top journal venues list you can get. So, A star, B star conferences you can get, right. So, you can refer the papers, recent papers, right, 2024, 2023 papers, and you will understand that what is going on, how the people are working and what problem people are tackling and what type of basically papers are coming, right. So, for example, many papers in NLP basically they are focusing on the data collection. So, you have prepared the data for low resource languages, you have done certain analysis, some analysis, then there is a high probability that you can get enter into these venues, right. So, just this was just information I just gave because someone of you asked that. Just a minute. Yes. So, simple is better, right. So, we want to do beyond explanation that are simples. So, how we basically try to provide explainability in the AI models. You have a real data, you have a trained model, and we generally perform the inference. So, once inference or basically response basically reaches to us, or response is generated by the model, we try to do explanation or we try to explain why we got this response or why this response basically occurred. So, in order to get this explanation, the idea is you have another approach, some algorithm which uses this model to basically try to respond to explainability. So, you have a data, you have basically inference, you have a model with you, you have to explain, right. So, this is the explainable module. So, maybe I can tell you one thing, explainability module can be, so this explainability algorithms can be model agnostic. So, model agnostic means it does not matter what model you have. So, model is black box for you, which just need input and provides the output to you. So, those algorithm directly you design the algorithm which can provide explanation on those models, right. So, we call it model agnostic, right, model agnostic algorithms. Another one is during the model learning process, during when you are designing, when you are basically training the model, you keep on basically explaining the things. So, whenever inference basically is out, it gives explanation, right. So, model itself provides the explanation, and another one is basically at the test time, right, when you deploy the model, you have algorithm which basically try to provide the explanations. So, that's why here you have we have a model agnostic and maybe you can say model specific explanation, right. In agnostic, right. So, and explanation can be provided at a two stage. You can say local explanation, right, and another one is global explanations. For example, ChatGPT, if you want to provide explanations, it might be you need a global or generic explanation. But for a specific task, if you want to provide the explanation, why translation module works, why image generation module works, text to image, right, why basically mathematical computation module works, right. in GPT or you can say in chat GPT or in conversational AI or LLM models, then those are basically you can call it just local explanation, and if you were taking all the things as a whole, right. So, it might you can say the global explanation we are just providing. So, scope and the approaches you know now. So, it might be model agnostic or model independent, it might be model specific, right. So, explanation you can generate for a particular model only, it might not be applicable for all. For example, gradient based approaches. So, gradient based approaches are model specific, if you are able to compute the gradient you can just do it. Something like you can just say that okay, feature importance you can identify even independent of model. So, you just need output, you need input, right. So, using input and output you can just try to get the gradient information. So, that is another story, but if you want to investigate inside the model, like you have GradCam and others, right. So, then they are model specific, only few models basically give this facility, right, not all. So, here black box versus interpretable models, complexity of models, you can say lack of transparency, trade off between. So, these are current challenges that we have, accuracy and interpretability, then local and global interpretability, we want model specific techniques, model agnostic techniques, right. So, increasing responsible AI development and deployment. So, that is the reason people are asking about the explainability nowadays. These are the tools, basically model agnostic or model specific basically methods, visualize and interpret, and you can integrate it. So, LIME, SAP, Interpret ML, AI explainability 360, AI fairness 360, right. So, explain like I am 5, it is yellow brick, what if, deep left, and another visualization tool is tensor board. So, tensor board you have a model and you just call this tensor board, it will basically draw the computation graph. So, once you have a computation graph, so computation graph also provides certain explainability inside the model, that how the model is, you can compute the gradient very easily and how the model works, right. You can visualize the computation graphs, you can visualize training parameters, you can visualize the matrix and hyperparameter values, right. And this basically somehow whatever you, if you have visualization, if you have certain understanding mechanism, so they provide certain explainability towards the model, right. So, this is the LIME usage of LIME for text data, how LIME works for the text data. So, you just see that the corresponding text is given, decisions are given, you just see that based on the color on these words, right, they have weightage for every word. So, in that piece of text that you have, so if you apply the LIME model, so it will select those words which has the highest probabilities, or you can say they have higher weight, and based on that they have a color palette, you can say that is pictogram you have. You just see for example, here text with highlighted words, like these words are important, right. So, 0, complaints, mechanics, capitalizing, ignorance, right, account, coverage, weighting, and accordingly you can say weights are here, right. So, you can say that what is the weight of word 0, what is the weight of second word, what is the weight of third word, fourth word, and so on. For positive, for 0 class, so if you want to predict anything as a 0 class, so what is the importance, what are the weights, or you can say values for the features that are important. In order to predict class 1, so these important features are there, complaints, mechanics, right, and so on, you can see their weights are there, you can say, and based on this, right, you can decision is made. So, this type of report is basically report is generated when you apply this LIME tool or LIME package on your model. So, any model you can just take and you will just apply this LIME approach, LIME basically package, LIME algorithm, and you will get explanatory like this. Then say for SAP features, SAP library is there, right? SAP library is there for eminence data. So we have demonstration. We'll show in the next post basically lunch session. So you just see that how it is basically giving the explanation. So you saw the why 7, its the model is saying 7, why model is saying 2, why model is saying 1, 0 or 4. So it basically try to get the SAP features, right? And most of the gradient, some gradients are also used here by the way, but it try to get this one. Then you can say fashion data. For fashion data, if you apply this SAP data, so you can say this how the features are here. So what are the regions which are important, what features basically it basically generated, and maybe if you are working in that, you might have seen this one. Why you are saying that this is a sandal? So what are the features? Suppose the first image you just see. So what are the features basically made this is a sandal? What are the features? You can say this is a bag. What are the features by which you can say this is a T-shirt? The first image. You know this is shoes, right? But you can say that what are the features which might try to tell this belongs to certain different classes, right? And the stronger the probability of the class, it will decide. So this type of visualization you can just see, and of course if your model is not learning anything, so it will not have a different color, different intensity, everything will be of the same color, right? You know that there is no decision making happening, model is bad. So likewise here you can see that this basically SAP applied on ResNet 50 model, and you know that ImageNet data. So yesterday we have discussed that it was trained on 1000 images, right? 1000 class data, including chair, table, and lot of objects, object classes are there. So you have a original image here. So if you want to get the prediction, apply the GradCam, just compute the GradCam heat map. So where are the gradients? You can say important gradients. So accordingly, this color, the dark brightness of this color, you can identify. So you can say that at the face, can you see that most of the brightness is at the face? So facial feature are important to tell whether this is basically this belongs to certain category, cat category or not. Then you can just superimpose the image here. You will see that what are the features in the image it basically looks into. Gives more priority, right? Then it basically tells about the Egyptian cat, and you can see the probability here. So class index is 285. So this model was ResNet 50 model has 1000 classes, right? So output layer has 1000 output, 1000 classes, 1000 neurons, and the neuron which has the higher activation value, or you can say highest value, so that class is assigned. So here Egyptian cat has a 0.45, you can say the 45%, you can say value out of 1000 classes, it has 0.45 value, and this is the highest one. If you want to display, you can display all these probabilities, right, for all the classes. Now can you say why the model works? This gives certain explainability, right? Why the model works, what are the features, right? So this is one of the GradCam, right? So approach, you can get the heat map. This is another data. So where you have certain basically images, these are the medical images, and bacteria are different class of basically bacteria are there, right? So you can see different type of infections you can see here, right? And why the model works? You can use Lime, you can use SAP approach, and they will give you the region from where the features are extracted, right? So important region in the image, and if you see that region is just a garbage, that is not useful, that is not ROI, right? So region of interest, then you say that model is not working well. But if you see that it is looking at a place which is basically ROI, region of interest, then you can understand that model is working correctly, right. So, this methods basically gives certain explanations, but you might rely on always on these things, right. For complex models it is very hard to get it right. Okay, what is the time right now? So, maybe 11:41. Maybe we can discuss few questions, right. So, one of the question I think there was there says, I think GPT, what was the question? So, I forget. So, नहीं अभी वाला जो क्वेश्चन आया था किसी ने भेजा है राइट लंदन ने जो क्वेश्चन तुमने क्या था. So, on LLMs, right. So, see interpretability on LLM is of course the challenging process. So, they said that can be get citation based response, right. So, like in Gemini, if you see Gemini, right. So, if you perform a query on Gemini, so it basically gives you the source, right. So, from where basically data is collected, response is made. So, there are variants, of course ChatGPT you can train in that direction. So, you can put the evidence there. Even nowadays people are customizing it with the certain evidence based response generation. So, whenever you say that ChatGPT or any LLM basically provides certain response, so what is the evidence? Suppose you say that okay, some response is made for a certain query and it provides the evidence. So, in the evidence let it basically gives you the evidence that is you know that is biased towards certain thing. From evidence you might know that whether the evidence is basically trustworthy or not. So, most of the time suppose I say news article. So, whenever it comes the problem is basically let fake news or hate speech detection or fake news detection. So, how can we detect fake news as a human? What is the idea? So, given a news maybe 1 or 2 or 3 sentences. So, as a human how do we rely on that? We see that source, who is providing the news, right, from where we are getting. So, if it is authentic, trustworthy basically news website, right, or the information that is we are getting is from trustworthy persons, we rely on that. So, in order to detect the fake and basically non-fake or genuine information, we have to rely on the source of the information. So, generally what happens, so we try to basically crowd you can say just collect information from many sources, do not rely on one source, then based on the majority voting you just say that the news might be correct. But many times we do not rely as a human, if something is not acceptable, right, in some sense. As a human we know that what might be obvious, what might not be obvious. Some common things might happen. So, suppose you know the pattern or some perception in the community you have against certain people, certain person. Then if something happens, then you know that person can do that thing, right. Many times if you know that some intelligent kid is there in the society and you say that that kid is basically selected in some of the top rank venues. So, people know that it is obvious the student is genius and he has been selected. But if you know that some student is there and that student that kid is basically very not intelligent in that sense, and you found that someone said that he got selected somewhere. So, that might not be obvious for you. You will say how did it happen, right. So, there are things, right. So, the source of information and the perception, the beliefs that we have, based on that we basically rely on the news. So, generally what we do, so generally we try to verify. So, there are, if you have a strong perception, you will not go for verification, but if you have little gap, little doubt, you will try to verify, right. So, you have source of information, even given the source, right, trustworthy source, you will try to verify, right. So, that is the story, and this is basically giving a lot of harm to the society. We are learning this CPS system, but you can say this is the another security threat, that fake news, basically spreading fake news. So, spreading fake news on social media sites basically tries to basically opinion shift. It basically decides on opinion shift. So, suppose you have spread certain news against certain celebrity or certain personality or certain person who has certain fame in the society or somewhere. If you spread fake news or bad news for a person, so if 1 or 2% rely on that news, right, then it basically harm that person. So, that is why fake news or these AI systems, that most of the time you can say AI systems are generating these fake news, right. You can say that fake videos, cloning, voice cloning, right. So, lot of things are there, so they are harming the system. So, we have to prevent it. So, in CPS, in addition to see that what data the models are stealing, what type of basically decision making the models are basically changing, we have to look into this aspect as well. But at the same time, if you say that we cannot, we should not do research, right, to generate the model, to generate the data, then you will not be able to compete with the current state of art, right. If you do not start using LLMs, if you do not start developing LLMs, so we will be the just user, right. So, if you want to compete with the current state of art, similarly you have to chase that, right. So, you have to work, you have to basically follow the research, current research that are going on, and accordingly you plan, right. So, that is a challenge here. So, evidence based solution is of course the need. So, citation based, I think her question was evidence based, by the way. So, we need response. So, that basically tells us the explainability, that explains, because we have collected this data from this source and we are giving the response based on that. Like in Wikipedia, you have a lot of evidences, right. So, a lot of citations are there, and if you see that those citations are trustworthy places or trustworthy venues where the paper or the article were published, you will rely, right. But if you say that some basically place, or you can say some organization which is not trustworthy, maybe, then if you say that center or that basically organization is spreading certain news or sharing certain news, that might not be correct. And this is a human perception, right. If we trust on a person, we trust. If we distrust, you say that okay, person is not trustworthy, so you will never trust, right. Are you getting my point? So, this is a true story, and so trustworthy AI is very important. Explainability basically is the way you can trust on the AI models, right, and we want to build our trust on AI models. If you do not have trust, you will not use. So, huge market is there, right. So, if people do not trust on your AI model, let DeepSeek is there and ChatGPT is there. So, let both are commercial model. So, we do not trust on let DeepSeek, let you only trust on Microsoft or OpenAI, then people go for OpenAI ChatGPT, right. So, that is a trust building. If you basically break the trust, or any organization, any society, any person, any object basically somehow breaks the trust, then that thing is not trustworthy. You never have a confidence, right. So, that is the story here. So, we will do these are the few popular tools, and maybe we will discuss few more tools in the post lunch session. And now I think we can discuss more on your problems. You just ask whatever you are doing, we can discuss on those problems, right. So, post bid session will have a half an hour discussion, right. So, where you just whatever problem you are facing, we can discuss on that, right. You just prepare your questionnaire, so we can do certain discussion, right. In the post lunch session. So, we are stopping here and we will meet, right. So, we have code, we will share the demonstration codes today. Okay. So, by the way, we have one more module in the demonstration session, that is basically network security. So, we have lot of modules there. So, you have intrusion detection system, malware detection, we have code for that, password breaking. So, how can you do brute force, how can you basically generate the password. So, what sort of things you can do. So, few codes we have, I will share you just go and practice. There are few bugs, I have intentionally put the bugs, you just try to remove and you just try to play, right. So, do not worry. So, in the post meet session we will do some fun, right, we will do some experimentation. Thank you everyone.